Hello everyone, welcome back to my channel. So in today's video we are going to discuss about mathematical induction. For mathematical induction, it can only give us proofs, it does not generate answers. Okay, as you can see on the board, this method of proof, it does not generate answers, it can only prove them. So in order for us to prove these answers, we need 3 steps involved, or 3 parts. The first part here is base case. For the base case, it can only prove one element. Okay, the given equation is supposed to give us only one element. When you substitute 1 on the equation, it's supposed to give you 1. Okay, then the second step here, or the second part, is what? Inductive hypothesis. For the inductive hypothesis, we try to introduce one number. For an example, we say this number or letter be k. For an example, if we have n, we say okay, let this be k. So now we try to substitute k. It will not give us answer. As I said, it can only give the equation when you substitute for the first value. Then we go for the third part, which is inductive step. For the inductive step, we check for the next highest value. Like for k, if we indicate k for the first value, for the second step, then when it comes to the third step now, we say let's an increment be in k. So we can say k plus 1. So that's the second highest step. As you can see here, it shows that it's true for the next highest element. Okay, so now we have an example here on the board. They said shows that the sum of the first n integer is n squared. Where p of this, probability of n, gives us the summation of these 2i minus 1 equals to n squared. So first, here, based on this statement here, the first n odd integer, as we know, the odd integer starts from here 1, 3, 5, 7, and 9. So now let's try to see. They said the first n integer, we can say, okay, let's the number of integers. Let's here, solution. Let's the number of integers. Integers be 5. Let's say here we just need 5 number of integers. So this first 5 number of integers, we need to add them. Okay, so now we say the first integer here, odd integer, is 1, and the second one is 3, the other one is 5, 7, and 9. So now we have these 5 integers, 1, 3, 5, 7, and 9. But they said was the first n odd integers, the sum of the first. So first we need to sum these integers, then we'll see what will be our outcome. So here 1 plus 3 plus 5 plus 7 plus 9. Okay, when you add this, you get 25. So 25 square of 25, because here they said n square. According to the equation, they said n square. The summation of these odd integers will give you n square. So n square here, 5 square will give you 25. So now we know the first 5 odd integers here is 5 square. So definitely we can use these numbers to generate our problem. Okay, so now we come to this part where they said the first part involved is what? Base case. The second one is inductive, and the third one is inductive step. So let's try first the base case. So for the base case here, as I said before, it can only give you, it can prove 1. Okay, if this element will give you 1, you add this one, this equation here, and this one supposed to be equal. If you have here 1, this one supposed to be 1 again. So now let's see for the base case, p of n from the equation is the summation of this 2I minus 1 to I equals to 1 is equals to n squared. So now say P of 1. P of 1 because n will be 1. According to this, it said it shows it's true for one element. So P of 1 now will be the summation of 1 over I equals to 1, 2I minus 1 equals to 1 squared. Okay. Then here I is equals to 1 again. So we move this one here, this equation. 2I minus 1 is equals to 1 squared. But I is 1, so 2 into 1 minus 1 is equals to 1. Okay, 2 minus 1 here, 2 times 1 is 2, 2 minus 1 is just 1 equals to 1. So this first rule shows that it is true for one element. Okay, so now let's see for the second part here is inductive hypothesis. For this second part, we let n equals to k. We let this n equals to k, or you can use any letter. We let here n equals to k. So now P of k, instead of this n now we use k. Then here k, then here k. So P of k, the summation of k into I equals to 1, 2I minus 1 equals to k squared. Okay? This one we can just state this equation. We are done. Just this equation. We are done with base case and inductive hypothesis. Now, we need to go to the next third part, which is hypothesis highest step. Okay, so now let's see here. We let n equals to k plus 1. Because they said highest step. We add here, we increase here, this one plus 1. Then I again is equals to k plus 1. So in this equation. So P of k plus 1, now we need the summation of k plus 1. Instead of k, now we say k plus 1. 2 into the I again is k plus 1. 2 into k plus 1 minus 1 equals to k squared. K squared, but k is k plus 1. So k plus 1 all squared. Okay? I here is 1. So in this equation, first we move this one here inside. This one inside, we move it outside. So our P of k plus 1 now will be 2 into k plus 1 minus 1 plus this summation. The summation of k, the summation of k to I minus 1. Of k to I minus 1. I equals to 1, which is equals to k plus 1 all squared. All squared. But you know, this one here, this equation here is equals to k squared. Let's see. Let's see here. We have 2 into k plus 1 minus 1 plus this summation of k, I equals to 1, 2i minus 1 is equals to k plus 1 all square. Okay? But this summation here is equals to k square. Is equals to k square. So first, we can expand this one. 2 times k is 2k plus 2 times 1 is 2 minus 1 plus, instead of this summation now, we use plus k square. Plus k square is equals to k plus 1 all square. So now 2k plus 1 plus k square is equals to, now we expand this. If we expand this, we'll have k square plus 2k plus 1. So let's see here, in case you don't know how to expand this, say k plus 1 into k plus 1. So first we multiply this k times k is k square, k times 1 plus k, then 1 times k plus k, 1 times 1 plus 1. So you add this, k square plus 2k, k plus k is 2k plus 1. So that's why we have here k square plus 2k plus 1. Therefore, we try to rearrange this one. K square plus 2k plus 1 is equals to k square plus 2k plus 1. Therefore, the highest element holds for k plus 1. Okay? So in this equation, you can see the left hand side here is equals to the right hand side. So our target in this equation is just for us to find if this left hand side is equal to the right hand side. Okay? So now let's take another example and see. Let's take another example.